Good morning, class. We are looking at statistics practice test number 1, module 1, covering chapters 1, 2, and 3. Chapter 3, describing, exploring, and comparing data. That's what we are looking at in this section. Describing, exploring, and comparing data. Could somebody read this question, please?
The following data gives the number of hours that a few employees at the GM factory worked last week. 17, 38, 27, 14, 18, 34, 16, 42, 28, 24, 40, 20, 23, 31, 37, 21, 30, and 25. Find the mean.
Perfect. Well, I like to rank it first, and I want to explain something to you, class. We don't need to rank data for some calculations, such as finding the mean. However, it's a good practice to do so for those calculations that need ranked data. If your question has a few parts, as this is the case here, and you need to rank it in other steps, you may forget. So that's the only reason I have ranked it. Okay. Now, we start with the formula. X bar is a summation of X over N. So we start from the first one, 14 and 16, all the way to the last one, 42. And we divide by size, N is 80. Now, when you write the answer, you want to be careful again with the number of decimals and you're rounding accordingly. So for example, if they want you to round it to the nearest hundreds, you need to look at this number to make that decision, okay? What about the mode? That's why I did the ranking. There is no mode. Why is that? Because nothing repeats. Mode is the one with the highest frequency of occurrence. Nothing repeats. Find the median. It's the middle value in the rank data. As you can see, we've ranked it here. So there are 18 pieces. So the middle of the data is right here between the 9th and the 10th one. So 25 and 27. Add them up, divide by 2. So between the two, 25 plus 27 divided by 2 gives us the value of the median. Mid-range. By definition, mid-range is the sum of the mean and max in any order, max and mean divided by 2. And it is the value midway between the max and mean and calculated as max plus mean divided by 2. And again, if I don't have it ranked, I make a mistake. So 42 and 14, add them up, divide by 2, we get 28. Range, by definition, is the maximum value minus the minimum value, which is 42 minus 14. We get 28. Please don't be under the assumptions that these two numbers are always the same. By no means. In fact, almost never. So note R and MR, meaning range and mid-range, are not equal in general. In this case, it happened by chance. And that's important to understand. It happened by chance. We want to continue. We want to find, really, we are interested in standard deviation, but we go through the variance first. And we recall from the previous page that the mean, or X bar, was 26.944. By the way, This was a sample because we are looking at a few employees. So we should know it is a sample, everybody, okay? And so reminding you of the formulas, we are going to use sample variance because this is sample. S squared is summation of x minus x bar over n minus 1. And this is shorthand notation, n summation of x squared minus summation of x quantity squared over n times n minus 1. And here's how you calculate it. I'm going to quickly show you both ways just for practice. Okay. But obviously, remember that this is done by, not by hand. This is not done by hand. And you do it through usage of technology. Okay. And so I just want to show you in case, because it's not a lot if you were to do it by hand and using this formula and then this formula. What is n summation of x squared? First of all, n is 18, we know that. Secondly, when we say summation of x squared, that means add them up, okay? So this is n 18, then summation of x squared, 14 squared, plus 16 squared, plus 17 squared, all the way to 42 squared, minus summation of x, add them up, and square that. So I want you to see the top. This is n, and this is n, and this is summation of x squared. This is summation of x over n times n minus 1. This is shorthand notation. Maybe I make this look a little bit better. Summation sign. Okay. And you do the math, and you end up with almost 75. As you can see, it's very close. But I also wanted to show you this method. How would you do that? If you want to go with this method, x minus x bar means 14 minus this number, square it, plus 16 minus this number, the x bar, square it, plus all the way to the last one, 42 minus this number, 26.944, square it, over 18 minus 1. Here's the formula. Here's the second method. You don't obviously have to do both, and it gives you the same answer, okay? 75. That's the variance. What is the standard deviation? Just take a root. And again, the number of decimals depends on what they ask you. Be very careful with that. Inner quartile range, or IQR. IQR, the IQR describes the middle 50% of values when ordered from lowest to highest, and it's defined as Q sub 3 minus Q sub 1. Q sub 2 is the same as median. Q sub 1 is the first quartile, and Q sub 3 is the third one. And there are different methodologies to calculate them. But Q sub 2 is very straightforward. It's the same as the median. We already did 25 plus 27 and divided by 2. But Q sub 1 is the median of the first half. Look at the first half. And the median is right here. There are 9 pieces. The fifth piece, which is number 20, this is the second half. The median of the second half, again, is the fifth piece, if you will, from here. Okay, from here, everybody. So this is the first one, second, third, fourth, fifth one, which becomes number 14 and is 34. Therefore, we write Q sub 2 is the median. We already calculated in the previous page. Q sub 1, median of the first half, which is 20, Q sub 3 median of the second half, which makes it 34. And we want Q sub 3, 34, minus Q sub 1, which is 26. And the answer is 14. The inner quartile range is calculated as number 14. So we have all the data, we have all the calculations in essence by hand, okay? You can use technology as long as you understand the concept class. So for example, if I want to use TI, the very first thing is I want to enter the data. To enter the data, I'm going to clear one of the lists, for example, L1. So I click on stat, clear list, some list, maybe L1, maybe L2, or highlight it, edit, and type in your data. So right now, I click on stat, I click on edit, okay, and clear list. I'm going to clear because I don't know if the list contains anything. I'm not going to take a chance. So I'm going to clear the list, one of them, for example, L1. And then I'm going to put in L1 the numbers, whether they are ranked or not. It doesn't matter. The calculator does everything for us. So type in the data in L1. Then next time we go to calculation, and select one for one variable and type L1. So now we go to calc, one variable stat. The list is L1 because we put everything in L1, and all you have to do, calculate. The moment you press calculate, it gives you some information, and there are a couple of pages, so you have to go down. I have both pages, notice, both pages, notice. This is the X bar with, of course, more decimals. This is the S. Now pay attention to S sub X versus sigma sub X. You should know which one you need. You should know whether you're dealing with a sample or a population. This is dealing with a few employees. You're dealing with a sample, everybody. Therefore, you want the S, not sigma. We have it there, again, with a lot more decimals. Obviously, you see n equals 18. If it was sigma, has a different value because you divide by n, capital N instead. Look at those values, Q sub 1, Q sub 2, Q sub 3, Q sub 1, Q sub 2, Q sub 3. By the way, it does have the minimum value and the maximum value as well. This is one technology, namely a calculator. Again, you have a lot of online calculators. I hope you've explored them and you got comfortable with one of them. Now, the same thing, we have the information. If you were to use Excel, you can input and select the data range, click on sort A to Z or Z to A, and you put the information. The moment you sort it, it puts it in the order, for example. And then to get the descriptive data, there are different methodologies. One is to make sure data analysis pack is added, data analysis, descriptive statistics, input range, so on and so forth. If you follow that, it gives you something like that. The input range, you highlight this part as a column, label in the first row. If you want the label, you check mark this and you include this in this part. If you don't want it, you don't. Okay. Output range, you can go with a new sheet, worksheet, or just click on this and pick cells of interest, any cell. And you click on summary statistics. So it gives you the information here. The mean, the standard deviation, the range, the mean, the max. If you want various quartiles, Q sub 1, Q sub 2, Q sub 3, here's what you do. You write down to find Q sub 1, okay, you put input range, cell 1, and the same thing for Q sub 3, min and max. And so example, quartile, D65 to D82, that would be in your Excel file. And if you click on 1, it gives you Q1. If you change this number to 2, it gives you Q sub 2, and it gives you Q sub 3. What I want you to know, the calculation of Q1, Q2, and Q3. Q2 is very straightforward. It's the median end of the story. It's universal everywhere. But Q1 and Q3, there are different methods to calculate them. The value that you find in TI and Excel may not be the same. However, two things. Number one, if the data is huge, they will become the same. Number two, if there's a discrepancy because they use different formulas, that's why if you show your work and we'll discuss it for the exam, you get full credit. You don't have to worry about the discrepancy. IQ scores have a mean of 100 and a standard deviation of 15. Find the coefficient of variance. So first and foremost, you're dealing with a population where mu is 100, sigma is 15. How do you know it's a population? Because it doesn't mention a specific size, sample size. So it pertains to the whole. So what is the coefficient of variance? It has, or CV, it has a definition. The coefficient of variance, or CV, describes the standard deviation relative to the mean and is used to compare standard deviation when the units are different. Therefore, the formula is sigma over mu. If you're dealing with a sample, it would be S over X bar. Okay, for a sample would be S over X bar. And we change it to a percentage. So it's 15 over 100, which is 15%. This is the coefficient of variance, the variation of standard deviation compared to the mean. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. Well, here's the range rule of thumb. Mu plus minus 2 sigma, or X bar plus minus 2S, because according to the empirical rule, if you go 2 standard deviations on each side, it covers 95% of the data, and that's usual and that's good enough. So mu plus minus 2 sigma, mu is replaced by 100. See how important it is to write the given. Plus minus 2 times the sigma, which is 15. So this is 30. (100 minus 30 is 70. 100 plus 30 is 130. So the range rule of thumb for us would be from 70 to 130. Using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130. Now, understand from here, we know from 70 to 130 means 2 standard deviations away. But I want to quickly show you, what if part B wasn't given? What if we didn't know 70 to 130 represents 2 standard deviations on each side? Here's how you find it. You put these 2 on both sides of mu. So you put, let me show you how to find. We know sigma is 2. We need the value of sigma. So here's number 70. You put the mu in between. Here's 130. Mu is given as 100. This distance is 30. This distance is 30. Or you can say the total is 60, either one. If you divide this one by sigma, which is 15, you get 2 standard deviations. If you divide this one by sigma, you get 4, which means everybody. The total distance covers 4 standard deviations. Each side is half of it, half of that. Or just calculate one side. By the way, they both must be identical on both sides. So you already know the number of standard deviations is 2 or k is 2. Okay. So let me clean up the mess. According to Chebyshev's theorem, the proportion of values from any data set that falls within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. So k represents the number of standard deviations away. As you see, from 70 to 130, we have 2 standard deviations on each side of mu. Therefore, k is 2. Again, we already know that. I showed you how to get a different case. Since 130 minus 70 is 60 and represents 4 sigma, k is the number of standard deviations away from the mean, half of that. So 4 sigma is the total distance divided by 2 gives you 2 sigma, and therefore k is 2. Okay. This is 1 over 4. And so 3/4, which corresponds to 75%. What about the empirical rule? Remember, the empirical rule refers to the normal distribution and a bell shape. So if you start from the mean and go 1 standard deviation away, you cover about 68% of the data. This covers 68%. If you start and you go 2 standard deviations on both sides, it covers 95%, and that's normally good enough. If you go 3 standard deviations away, it covers almost everything, which is 99.7%. So 95% will have an IQ score of 70 to 130, because 70 to 130 are 2 standard deviations away from the mean. Given the data, rank it from smallest to largest. Very straightforward. Obviously, 3 is the smallest number, 50 is the largest number. So you rank. We want to come up with the box and whisker plot. We need 5 measures. Minimum, maximum, we got them. We want Q1, Q2, Q3. And there are different ways of approaching them, and I'm going to explain that. First and foremost, we cut them in half. So right here is the median, which is 15 plus 15 divided by 2, or 15. So this is the median. The first half we want the median of the first half. There are different ways to calculate Q sub 1 and Q sub 3. This is universal. You never go wrong with that. There are different approaches. If you go with the median of the first half, you get 7 here because you have 1, 2, 3, 4, 5, 6, 7. So you need the fourth one. If you go with the median of this one, 1, 2, 3, the fourth one is 19. And that works out, and it's very easy. However, the other methodology in this case happened to give you the same thing. We have how many pieces of data? 14 pieces of data, that's n. And we have a formula for the locator. N is 14, locator L is k over 100 times n. In this case, when we say k is really the percentage, and remember quartile, the first quartile is 25%. So this is 25%, 25 over 100 for Q sub 1. For Q sub 2, 50 over 100. For Q sub 3, 75 over 100, 0.75 or 75%. Therefore, Q sub 1 is 25%, and now replace the k with 25. When we do the math, we end up with 3.5. Now, 3.5, we always round up, becomes the fourth one. And The fourth piece of data is number 7. Q sub 1 becomes 7. If we had gone with the method that the median of the first half, in this case, it would have given you the same answer. For Q sub 3, we go with 75%. So in this formula, we replace the K with 75, becomes 10.5, and we go with the 11th piece. And 11th piece is the same as what I mentioned before, is 19. Now, how do we come up with a whisker, box and whisker plot? We go on a number line. We put these numbers in order. The minimum, Q sub 1, Q sub 2, Q sub 3, and the maximum. So we have a number line. We put those numbers. The min and max are part of the whisker. The Q's are the part of the boxes. Just, just to give you an idea, so roughly you graph this. Let's say this is 3. Let's say this is 50. Let's say this is 7. Let's say this is 15. Let's say this is 19. You make up a box here. Okay. And those are the tails, the whiskers, if you will. That's the idea. Let me show you, of course, a better graph. This is the line. On this line, you check mark the numbers 3, 7. The minimum is 3. Q1 is 7. Q2 is 15. Q3 is 19. Maximum is 50. So that's, you put them in order. This would be your box, and this would be your whiskers. Take a look. That's how you do that. Okay. So you need 5. If they said 5 numbers summary, those are the 5 numbers you need. All right. We are looking at the same question. Does this data set contain any outlier? Make sure to show the lower and upper fences on your graph. First of all, outliers, simply put, means something which is out there, which is way off. And you can sometimes look at it and see which number is way off, but we want to do it mathematically. I want to look at that. And again, we have the information here, and of course, with the mean and max. Mean is 3, max is 50, just because you need 5 numbers. I want you to know that. So here's how the definition in statistics work. The value for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 IQR are the fences that mark off the reasonable values from the outlier values. Outliers lie outside these fences, okay? So the first thing we need to calculate is IQR, which by definition is Q sub 3 minus Q sub 1, and it makes it 12. So since I need 1.5 times that, let me multiply this by 1.5 and I get 18. So Q sub 1 minus 1.5 IQR means Q sub 1, 7 minus 18. So any number less than negative 11 is an outlier, of course, with our negative numbers. So no worries. Any number larger than this, so Q sub 3, 19 plus 1.5 times IQR, 19 plus 18 is 37. Any number larger than 37 is considered an outlier. Do we have any number larger than 37? There is one, and that's number 50. 50 is larger than 37. Also, You have something called extreme outlier. Instead of 1.5, they use 3. So Q sub 1 minus 3 times IQR. I just wanted you to know that. So if you multiply the IQR by 3, you get 36. So Q sub 1, 7 minus 36. Q sub 3, 19 plus 36. So if it's beyond this number, if it's smaller than, we don't have to worry about negative, we don't. If it's beyond this number, if it's larger than 55, it's an extreme outlier, we don't have any. Finally, the question is, are the data symmetric or skewed? If skewed, are they skewed to the left or right? And again, this is the information from the previous page. Let's explain a couple of things. Number one, make sure the drawing is to scale. If this is not to scale and we drew something, it may not show whether it's skewed or not. Number two, skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right or positive skew, or the mean is larger than the median. Longer part on the left or below the median indicates data is skewed to the left, meaning negative skew, meaning the mean is less than the median. Also, you want to pay attention to all these notes. Sometimes the box may look even or uneven and even skewed to one side. However, the whiskers or the tails on each side of the box may indicate otherwise. Therefore, pay attention to both. So the fastest and easiest way is to draw a line and look at the Q sub 2. Which one is longer, to the right or to the left? Clearly to the right. So it is skewed to the right. Skewed to the right meaning what? Positive skew, the mean is larger than the median. Again, if this is to scale, it's easy to see the answer. And as far as the skew is concerned, it looks like this, okay? Something like that. All right. For the following, draw the box and whisker plot for the following data set. And as you can see, on purpose, the data set is small and it is given in ranked format. It's already sorted. We don't have to sort it again. So it makes life easy. Let's cut them into two equal pieces. The median is easy, it's somewhere here. That means add them up, divide by 2. 86 and 87 divided by 2 is 86.4. As I mentioned, there are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way. This splits the limit into two halves. The bottom half, the top half. Since the halves of the data set each contain an even number of values, the submedian will be the average of the middle two values. Again, this is one easy way to do that. So for the bottom one is here. 79 plus 80 divided by 2 is 79.5. And for the top one, 87 plus 94 divided by 2 or 90.5. So we can calculate Q sub 1, add these two, divided by 2. And for Q sub 3, add these two, divided by 2. Five number summary. We need the minimum, we need the maximum, and we need the Q sub 2, Q sub 1, Q sub 2, Q sub 3. So let's write all those five numbers. The mean is 77. Q sub 1 is 79.5. Q sub 2 is 86.5. Q sub 3 is 90.5. And the maximum value is 99. So you draw a line and you put those numbers, and this is your box. If you draw a line, Q sub 2 appears to be in the middle of this red line. Almost, not 100%. So data is almost symmetric, normal, bell shape. Now, I want to add a few things. They haven't asked, but I want to add a few things quickly, okay? For example, if I were to find the outliers the way it is, I need IQR, which is Q sub 3 minus Q sub 1. I'm going to multiply it by 1.5. I'm going to subtract it from Q sub 1, and I'm going to add it to Q sub 3. So let me quickly show you. If they ask for outliers, Q sub 3 minus Q sub 1 is 11. 90.5 minus 79.5. Again, they haven't asked for that. So Q sub 1 minus 1.5 times IQR, well, 1.5 of 11 is 16.5, so we get 63. And then Q sub 3 plus this number, we get 107. If we were going with extreme outliers, then we have to multiply this one by 3, everybody. And subtract it from Q sub 1, we get 46.5. Add it to Q sub 3, we get 121.5. They didn't ask, you don't have to worry about it, but I just wanted to show you in case. Again, note, if n is odd, let's see what happens. I just added a number on purpose. I wanted to show you something. Clearly, Q sub 2 is 87, no questions asked. The one in the middle, there are 9 of them. The fifth one is Q sub 2. What about Q sub 1 and Q sub 3? Here's an interesting methodology, 2 ways. Sorted lowest half, including the median. If you include the median as part of the bottom half, AD becomes Q sub 1. And if you include it as part of the top half, 94 is the middle of the data, becomes Q sub 3. In some cases, they don't include that. So there are different methodologies. I wanted to mention that again. When you have odd number, so the Q sub 2 is the middle of the data, and for the bottom half, you can include it for the bottom half as well as top half, or you can exclude it from both. I didn't exclude it here because normally they include it. However, I mentioned it to make sure everybody knows there are different methodologies, everybody. Okay, there are different methodologies to find Q sub 1 and Q sub 3. All right, if the mean of a set is given as to be 23, and 12.6 has a z-score of negative 1.3, then the standard deviation must be. We write the formula, and before we write it, what is given? Mu is given as 23. 12.6 is some value, we call it x, with the z-score of negative 1.3. So this is the given, everybody. We know the formula z equals x minus mu over sigma. We have everything and sigma is missing. I hope you realize you can do the cross product and z and sigma can interchange. Take a look at these formulas. Okay, I can put the sigma here, z here, because of the cross product property. Now I have the given, plug in. 12.6 minus 23 over negative 1.3 is 8. Therefore, the answer must be D. The answer must be D. Find the z-score for each student and indicate which one is higher. For the art measure, I'm going to call it AM. For the theater measure, I'm going to call it TM. The X was 46, X bar was 50, S is 5. And for the theater measure, X is 70, X bar is 75, S is 7, which means in order to compare two different things, we have to calculate the z-score for each case using X minus mu over sigma, or in this case, X minus X bar over S. So for the first one, 46 minus 50 divided by 5. This is for the art measure. We end up with negative 4 over 5 or negative 0.8. Now, before we move on, a negative z-score doesn't mean a negative score. As you can see, the score is not negative. A negative z-score means the score is less than the average. A positive z-score means it's greater than the average. We do the same thing for the theater measure. 70 minus 75 over 7, and that is minus 5 over 7. To understand that and compare it, we're going to go with decimal notation. Now, as you can see, both of them are negative, but this one is larger than this one, right? Because this is closer to 0, right? So therefore, the answer is C. The theater measure has a higher score than the art measure. So this one has a higher score. Not because of the X value, okay? Because of the Z score. Could somebody read the question, please?
If the 5-number summary for a set of data is 0, 3, 6, 7, and 16, then the mean of this set of data is A, 6, B, there's insufficient information to calculate the mean, C, 8, D, 5.
Excellent. Well, as you know, when we want to calculate the mean, we need all pieces of data. So clearly the answer is B. And again, the reason is the formula. X bar is summation of X over N, or mu is summation of X over capital N. So to find the mean, add up all values in the data set and divide by the number of values. We need all data to do so. Therefore, we don't have enough information. Which of the following is true? Well, in order to know what is true, we need to have a definition. So the true statement is answer B. Why is that? Well, D represents deciles, measures of location that divide the data into 10 equal parts. P represents percentiles, measures of location that divide the data into 100 equal parts. Q, quartile, measures of location that divide the data into 4 equal parts. Therefore, D5, P50, and Q2, they all refer to the middle of the data in essence. Could somebody read this question, please?
A student received the following grades: an A in statistics, 4 credits, an F in physics 2, 5 credits, a B in sociology 3 credits, a B in a literature seminar 2 credits, and a D in tennis 1 credit, assuming A equals 4 grade points, B equals 3 grade points, C equals 2 grade points, D equals 1 grade point, and F equals 0 grade points. The student's grade point average is weighed mean.
Excellent, excellent. For a case like this, we use what's called weighted average or weighted mean. This is how your GPA is calculated, so you really should learn this. And it's important, the concept, why it works that way. So let's first define this. When different X data values are assigned different weights, W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. So we have the following grades, their weight or the number of units, and how much they are worth. A is worth 4 points, F is worth 0 points, so forth. So forth. These are the number of units we are taking in this case, we are dealing with in this case. So the formula is X bar is summation of WX over the summation of W. And the reason it works this way, it's very simple, class. If you happen to have 1A and 1B, the average is not necessarily 3.5. 1A, 1B, maybe or may not. It's 3.5 if they have the same number of units. But if A course is 4 units and the B course is 2 units, it must be more than 3.5 because in essence you have more A's than B, right? 4 units of A, 2 units of B. That's why we use the weighted average. So according to this formula, we multiply this column by this column and we divide by the sum of this column. So according to this formula, 4 times 4 plus 5 times 0 plus 3 times 3 plus 2 times 3 plus 1 times 1, and we divide by the sum of this weight column. (16), this is 0, this is 9, this is 6, this is 1. They add up to 32, and then this is 4, 5, 9, and 12, and 14, and 15 units. And normally they go with 2 decimals. I'm choosing to go more, but you want to pay attention to how they want it. So this is how your GPA is calculated, everybody. Given the data set 10, 44, 15, 23, 14, 18, 72, 56, find the value corresponding to the 75th percentile. So number 1, let's rank the data, sort the data from smallest number to the largest number. So obviously 10 is the smallest, 72 is the largest, and the rest are in between. That's the very first step we need to do. Then I'm going to remind you of this formula that I gave you. In this case, n is 1, 2, 3, 4, 5, 6, 7, 8. In this case, n is 8. L was k over 100 times n. We want 75th percentile or 0.75. In essence, it's multiplying the percentile by n to locate its location. So in this case, 75 over 100 or 0.75 times n, which is 8, becomes 6. Now, what statisticians do, because this is a whole number, they go in between, they go between the 6th and the next one, okay? A 7th one in essence. So 1, 2, 3, 4, 5, 6, and 7. They go in between. 44 plus 56 divided by 2. That gives us 50. Now we want 30th percentile. So over here, change the K to 30 and N is still 8. And it gives you 2.4. Now, they always round up. If it's 2.1 or 2.7, it becomes the third one. So they're going to go with the third one. 1, 2. The third one is 50. We want to find the percentile corresponding to some number, in this case 44. The methodology is that the number of values less than whatever, in this case 44, divided by n, that gives you the percentile. Okay, so percentile is the number of values less than 44 divided by n. So less than 44, we have 1, 2, 3, 4, 5 of them. 5 over 8. That's the answer. Change it to a percentile. Change it to a decimal and then percentage. So 5 over 8 is the answer, but we want it in a percentile format. This becomes 0.625, and normally we go with 2, so P63. This one we rounded accordingly. Using range rule of thumb, estimate the standard deviation. And I'm going to remind you of the range rule of thumb. Mu plus minus 2 sigma, or x bar plus minus 2s. Range rule of thumb for estimating a value of the standard deviation. As you can see, the distance is about total of 4 sigma or 4s. To roughly estimate the standard deviation from a collection of known sample data, s is the range divided by 4. And as you know, the range is max minus mean. 72 minus 10 divided by 4. That means 62 divided by 4, and that's 15.5. 15.5. That's how you find the standard deviation roughly from the data. Of course, as you know, you can calculate it using formulas, okay? The precise answer uses this formula, the square root of summation of x minus x bar quantity squared over n minus 1. You can go through that and find it. It should be close to that. Of course, it won't be equal, but it should be close. Could somebody read this last question? You don't need to read the numbers. Go ahead.
The following data representing numbers of keyboards assembled for a sample of 25 days in a company. Construct a frequency distribution table with 4 classes.
Excellent. All right. First and foremost, we are going to rank the data from smallest to largest. Looking like that. The smallest one is 41, the largest is 56. We want 4 classes. The width roughly is the range over the number of classes. We want to know what should the width be if we want so many classes, 4 classes, 5 classes, 10 classes. Normally you choose on your own. For the sake of this example, I'm choosing it for you. So the width is range over the number of classes, and of course you're going to round up to be on the safe side, and I'll tell you why we round up in a moment. So 56 minus 41 divided by 4 classes. This becomes 3.75. Now, we must round up. Here's the reason. If you don't round up, you will not, by the time you finish with your classes, you will not have all of those data. You will miss some of it. And You can stick with 3.75 and that gives you all of them, except it's not easy to work with. So it's a good idea to round it to a nice and easy number. It so happened the width is equal to the number of classes. That's not the case always. It just happened, okay? And so what do we do next? We need to find a lower limit of the first class. So lower limit of the first class, the starting point is a convenient number. So it's up to you, which is less than or equal to the smallest value, such as 41. Here's the smallest value. You can say, I'm going to start with 40, and that's fine. Or you can say, I'm going to start with the same number, 41. That's fine. The only thing is, if you start with 40, make sure by the time you finish, 56 is there. If you finish your job, 56 is there, 40 is an excellent choice. No problem. But if you have any doubts, you start with 41, which means 41 to something, and the rest of them we don't know. We just choose 41 as the first limit, the lower limit of the first class. Well, we decided the width is 4, right? So remember how we calculate the width? We add 4 for consecutive ones. So for example, here would be 41 plus 4, which is 45. You see that? So you keep on adding 41, 45, and 4 is 49, and 4 is 53. What about here? Remember when we were dealing with one class, we said the width is the upper limit minus the lower limit plus 1 unit. So for this one, the width is 4. The upper limit is missing. The lower limit is 41 plus 1. And I hope you see that we have minus 40. When we move it to the other side, becomes 44. Therefore, this number, let me use a different color. This must be 44. And now what do? You add the width 48, add the width 52, add the width 56. That's how you get these classes. Now, 41 to 44, for example, 41 to 44. So we need, just for the sake of argument, we need those, right? So let's write them. And for the first one, we have how many pieces? 5. Now from 45 to 48, we have those. Or this one, right? 1, 2, 3, 4, 5, 6, 7, 8. And you can write the rest of them. So this is the frequency distribution table for the data. So I hope everybody's clear how easy it is to make this up. Now, we are looking at the same question. We have the information from the previous page. Now we want to find the mean. Well, we have the data. So from the given data, we find the exact answer. So we add them up and divide by size. There were 25 pieces. So X bar is summation of x over n. I didn't even look at the ranked one. 45 all the way to 42, this is another ranked one, divided by 25. And we know precisely to be 48.48. We can calculate the x bar because we have every piece of data. Now, what if we want to use the frequency distribution table to find the mean? This is an estimate, remember that. Okay. So we use the following formula. X bar is summation of f times x sub m over n. And please understand this is an estimate. F is the frequency. X sub m is the midpoint. Okay. So FDT does not give us every piece of data. So we use x sub m, which is the midpoint of each class. What does it mean? In this class, all of them may be 41, all of them may be 44, or some of them 41, some of them 42, some of them, we don't know if we are looking at this one. So what happens is that they assume all of them are equal, they're equal to the midpoint. That is a conservative estimate. And the midpoint is 44 plus 41 divided by 2. 85 divided by 2 is 42.5. So as an example for this one, the midpoint, which is the upper limit plus the lower limit divided by 2 is 42.5. We can calculate the rest or just add the width. Remember the width was 4, so add 4, 46.5, add 4, 50.5, add 4, 54.5. So here's the midpoint. So you calculate one of them and add 4. So according to this formula, multiply these two, multiply these two, multiply these two, multiply these two, add them up and divide by n, which is 25. So 5 times 42.5, 8 times 46.5, 8 times 50.5, 4 times 54.5. We add them up, divide by 25. And if we do the math, we end up with 48.26. So I want you to pay attention to the exact answer and what we just got. That's a pretty good estimate. Are the two means reasonably close? Yes, they are reasonably close. Again, this, we have all the data. This we don't, but this works out pretty good.